Hello everyone, welcome to the Microdesk webinar series. My name is Megan Fulligar. I'm the marketing manager here at Microdesk. Welcome to today's webinar, What's New in 2013, Revit Structure. For those of you who aren't familiar with us, Microdesk is an Autodesk Gold, Oracle, and Google partner. We provide technology training and consulting solutions for the AEC industry. We have 12 offices located throughout the East and West Coast with a staff of over 90 consulting and technical specialists. The new Autodesk 2013 products have come a long way. Over the next hour, we will take a look at just how far Autodesk solutions for structural engineering have come and dive into the best new features of Revit Structure 2013 and how they significantly improve integration, collaboration, and interoperability. Presenting today's session, we have with us Microdesk Solutions Specialist, Henry Herrera. Henry is a structural engineer by trade with expertise in structural design, 3D modeling and design, and construction documentation, leveraging building information modeling technologies, including Revit Structure and AutoCAD. As a Microdesk Solutions Specialist, Henry provides technical support, training, implementation, and consulting services to structural engineering clients on strategies for integrating BIM into their design processes. Just a few logistics before we begin. In order to minimize any background distractions, you are all on mute for the duration of the session. If you have any questions during the presentation, please type them into the question area of the webinar toolbar to the right of your screen. Henry will address as many questions as he can at the end of the presentation. If we run out of time, we will provide you with our contact information so you can follow up with us. And now I will turn it over to Henry.
Thank you, Megan. Today we'll be talking about the updates and changes for Revit Structure 2013 and how they may benefit your workflow in design and documentation. Some of the key features that can be broken down into three main categories: Revit rebar enhancements, analytical modeling improvements, and interoperability and collaboration tools. The integration of the Autodesk 360 Cloud is also a tremendous update, where tasks can be performed over the cloud, such as energy analysis, rendering, and structural analysis. I will now go over some of the rebar enhancements that will be beneficial for design and documentation. For 2013, area and path reinforcement has been updated with a new behavior that makes these elements function in a similar manner as beam systems and structural framing. The creation of these elements stays unchanged. Each is created using the same sketch editors, and the symbols and tags remain the same. However, the main difference is that structural rebar elements will now appear in the floor or wall and can now be properly scheduled. Rebar sets will be created when possible, and individual bars will be created when sets cannot be defined. For example, along an arc. Welded wire fabric has also been integrated into Revit Structure 2013 and can be modeled and scheduled the same way as path and area reinforcement. Let's now take a look at some of the updates pertaining to analytical modeling for Revit Structure 2013. In this release, you can find many enhancements to help create and manage the structural analytical model, such as better visibility and greater control over the analytical model. Analytical floors and analytical foundation slabs now have corner nodes in analytical edit mode. If you select the analytical model, you will see controls posted at all corners and edges, which allow direct manipulation of the analytical model. You may select individual edges by using the Tab key while hovering over an edge. For the first time, you now have the ability to bring in Revit files directly into Navisworks. You no longer have to spend time exporting your file to Navisworks, and you also do not have to spend time breaking your file out by levels, which in the past was the best practice. Now, because they have incorporated the Revit hierarchy into Navisworks, they have also utilized the ability to select objects in Navisworks by level, family type, object, and material, straight from the selection tree in Navisworks. These functions alone will save you time and headaches when trying to coordinate between multiple models and disciplines, allowing you more organization and less time thinking about how you need to organize the model before it goes into Navisworks for a clash detective. Autodesk 360 provides users with various tools to be performed on the cloud. We will specifically demo the Autodesk 360 structural analysis tool to give insight to how this may be beneficial for design and documentation. So we're going to start out with a demo of the rebar enhancements as well as the analytical enhancements. And what we're going to do first is, from scratch, we're going to develop a concrete model. So we're going to start out by first generating our vertical grids and horizontal grids. And we're going to first space the grids out by 20 feet. And we'll do the same thing horizontally. Again, we're just going to make a simple box here, spaced out by 20 feet as well. I'm now going to go to our wall tool, and I'm going to find a concrete wall here. I'll choose an exterior 10-inch concrete wall to create. And I'll use my draw command here to draw a simple rectangular box. And now on the first level, here at the foundation level, I'm going to attach wall foundations to my wall that I just created. And we'll jump back to our floor level, and we'll create a floor slab. And I'll go ahead and choose a 6-inch concrete slab, and we'll just draw it around the walls, lock it to the walls, and click the check mark to generate the slab. So our slab has now been created. I will now go ahead and create a 3D view so we could see, what we have created so far. I'm going to put on a realistic view here. You can see we have our walls and we have our slab right on top of our walls. Now going back to our plan view here, I'm going to go ahead and move in our elevation markers so that they're all around our structure. I'm going to go ahead and go to our east elevation, and I'm going to start to use the area reinforcement tool for the east wall. So I'm going to go to my Structures tab and go to the Reinforcement panel and choose Area Reinforcement. Once I have chosen the tool, I can go ahead and tab through the elements and choose my wall. And it'll take you into sketch mode where you can define the perimeter of where your area reinforcement is intending to go. And you could change the direction of your reinforcement. We'll go and do this for each wall using the same method, going to the elevation view, putting in the reinforcement using the area reinforcement tool. Same way, using the rectangle tool under sketch mode, we're generating our area where our rebar is going to go. Once we finish that, finish the command by clicking the checkbox, check mark. And so on, and we'll do it for the rest of the walls. And the reason why I'm doing this is so that we can actually see the rebar modeled inside the wall. So after we've placed all the rebar using the area reinforcement tool, I'll go back to our default 3D view and turn off our walls so that we can see what has been modeled, and we can see how it looks like in 3D. And our final wall here, same method. Select the wall, area reinforcement, and place it. And you're going to notice that the properties of that reinforcement are on the properties palette, and if these rebar sizes change, they will change in the 3D model as well. So anything that changes and is scheduled will change with it. So now that we've placed the rebar in the walls, I'm going to go ahead and use the path reinforcement tool. And we're going to put in some rebar from the slab into the walls. So we're going to dowel into the walls. So we're going to select our slab. I'm going to draw my path. And you can see that the black line represents how deep the hook will go into the slab. And we'll see how that will look like in 3D as well. Finishing drawing in this final side. I'm just going to do 3 sides for now so we could get an idea here and see it better in 3D. And now I'm changing the length that will be doweled into the slab itself. I'm pressing the check mark. The path reinforcement has been created, tagged, and now we could go to a 3D view and see what we did so far. So here's our basic model. I'm going to go to our visual graphics overrides, and I will be hiding the walls and the floors so that we only see reinforcement. Once I click apply, you'll see that we have our bars there. We do have the analytical model turned on, and let's go ahead and turn that off. And you can see that using the path reinforcement and the area reinforcement tools, we now have modeled rebar in 3D that can be scheduled and with any schedule within Revit Structure, just like any other object that is modeled in 3D. And the objects are smart so that if I go ahead and change any property under the properties palette, it will change in 3D. So we could select the path reinforcement here. And let's go ahead and change the primary bar length so we can see how it flexes. There you go. Now the primary bar length is now increased to whatever value I inputted in the properties palette. What I'm now going to do is create a foundation slab, a slab on grade, and I am going to use the new fabric reinforcement tool and show you how it's used. So we're going to go to Foundation Panel and select Structural Foundation Slab. Just going to draw a generic box here, just a generic slab, 6-inch foundation, concrete foundation slab. Click to finish the command. Let's go in 3D to see what we've done so far, and there's our foundation slab. Now, I'm going to go ahead and select my slab and use the Fabric Reinforcement Area tool. And it'll put you out into sketch mode, very similar to the path reinforcement and the area reinforcement tools. And here you can choose what type of fabric sheet you're intending to use, your major and minor splices, and so on. So I'm just going to choose a sheet here and just draw it into my slab. I'm going to lock it to my slab area so that if my slab was to change shape, the reinforcement will change with it. And you can see now that we have different sheets of fabric, and the parameters can be changed as well. So if, for example, if you want to change the length or the width of the sheet itself, it's very easily done by going to the type properties of the sheet and changing it within that window. So we'll go ahead and do that. So I'm going to go ahead and change the overall length. Maybe I want it smaller. Maybe I want to change the width, and so on. And you could see how in the model itself it will change and flex for you. So now if this information was being scheduled, you now have a lot more sheets that are appearing on your schedule. You can very easily see the overlaps of the fabric as well. And so we'll go back to our 3D view here. And just like how we did for the walls and for the floor, I'm going to go ahead and turn off foundations so we could see the sheets themselves. And here we have our fabric sheets, how we define them within the properties palette. And like I mentioned before, all these elements can be scheduled just like any other modeled element within Revit. So what we're going to show you next is the Analytical Enhancements for Revit Structure 2013 and how to export that into the cloud for analysis. So very similar to the previous example, I'm going to start out fresh with the fresh template and just go ahead and draw a couple grids here. I'm going to draw my vertical grids, space them out at 20 feet. I'm going to draw a couple horizontal grids as well. Space them out vertically by 20 feet. Use my copy command. Now I'm going to start to, again, like before, we're going to look at our elevation marks around our structure. And I'm going to start to create a steel structure, steel frame, a box. So I'm going to start out by inserting columns. I'm going to insert them at selected grids here. So I have 4 columns. Now I'm going to connect them with beams to make a box. Okay. The next thing that I'm going to do here is to draw an eccentric beam off the side of this column that we've zoomed into. So what I want to do is model this eccentricity into that column so that the column can be designed for the extra load. By default, what Revit's going to want to do is it's going to want to attach the analytical model to the column, but we'll fix that in a second. And while we're here in this view, I'm going to start to add boundary conditions to the bases of my columns. And now I'm going to go to a second floor analytical view. And you can see how the beam is skewed. Even though I drew it straight, it's still the analytical model is trying to snap to the column. So we're going to go ahead and fix that by going to Analytical Adjust. Select the beam. We're going to pull back the analytical model. And then I'm going to pull it forward so that it aligns with the perpendicular beam here. And you can see our offset right there. And I'm just going to use Analytical Link to add a rigid link from beam to column. I'm going to go ahead and finish the command here in a second. And you can see in 3D as well that that beam is attached with a rigid link as well. I'm just going to go ahead and change the releases for all the beams for now and finish the command. And you can see that our physical model is behaving the same way. It's not skewed or anything. So next, I'm going to start to create a couple load combinations here. I'm just going to add a basic one, just one. I'm going to add a 1.2 dead load plus 1.6 live load combination. Add my factors. You can see how the formula is changing up above for the factors for dead load and live load. And now I'm going to start to apply a couple loads here so that we could send it out for analysis. So what I want to do first is go to any analytical view, because you could only apply loads in an analytical view. And I'm going to just put on a couple of line loads here. So I'm going to choose and change the scale of the line load so that it looks smaller, and change the magnitude. Perhaps this is a typical floor dead load. So I'm going to go ahead and apply it to my beams. And again, I'm going to do the same thing for floor live load. Change the magnitude and apply it. You can see that the different loads are shown in different colors as well. And in either view, you could see your loads. And before we send this out to analysis, I want to also draw in concrete slab. So we're going to create a floor, a structural floor. Use my rectangle tool this time, and just draw a simple concrete slab here. we'll call this a 6-inch concrete slab. Finish the command. We have our slab there. I'm going to start to penetrate this slab with a couple of shaft openings so that we can see how those tools work now as well. You'll notice that I'm putting in these shaft openings all within the same sketch mode. So what Revit is going to do is combine them as a group. So if I wanted to turn them off, and we'll see that in a second, it's going to turn the whole group off. So going back to our analytical model, select our slab, go to Analytical Adjust, and go to our Openings button here. And you'll see that there's a little checkbox that comes up. And if I uncheck that, the holes will go away. They may physically be there in the Revit model, but they are not going to be used for analysis in an analytical model. So if this was sent out to the cloud or to Revit Structure, it wouldn't analyze the holes. So I'm going to go back and create a couple more shaft openings. Before I do that, I'm going to turn the original ones on and create a second group here. Again, I'll use the rectangle tool with sketch mode. Finish the command. Now if I go back to Analytical Adjust, go to Openings, you'll see now I have a different box for the second group. So I could go ahead and just turn those off for analysis if I intended to. So we'll just keep these for now and start to put in some structural loads and boundary conditions. So I'm going to go ahead and do a continuous support along the slab on all sides. And start to create a couple of area loads. So I'll put in a typical floor dead load first and change the magnitude here. Select my slab and you can see the loads coming in. The loads initially will come in pretty large, so I'm going to go and change the force scale so that it looks smaller. That looks a little better. And same thing, I will add a live load here. Change the magnitude. Choose my slab, and there's my live load. Okay, so these elements are now ready to be thrown into the cloud for analysis, for preliminary analysis. So what I'm going to do is go to my Analyze tab and go to Analyzing Cloud. When you click that, it will send this information out to Autodesk 360 for analysis. And just so everyone knows, the analysis is a static analysis only, and it'll do whatever you have in your view. So in this case, I have a slab and our set of frames that we initially modeled here. And it'll open up a connection to Autodesk 360 via the Autodesk website. And just give it a sec here. We're going to see what we've done so far. So here's our analysis in Autodesk 360. We could select it and look at what it has done so far. I'm going to go ahead and select it and view the results. And the great thing about this is that you can send multiple analysis over. So if you're interested in, only the wind frames for your building, you could just analyze the wind frames or analyze just a specific slab or specific column or anything that you're interested in looking at. You could send them all simultaneously to Autodesk 360 for analysis. So we're going to go ahead and look at what we sent over. You can see that it starts to give you a generic view of the model. It divides the slab into finite elements for you, and you have your steel frame. You have all your load cases, your load combinations, and then you can start to look at results like reactions for all the different cases here. You can keep on going. You can look at displacements, forces and members, forces in columns and beams. So you can start to get an idea of how your structure is behaving while you analyze or while you design your project in Revit Structure. And not just the beams, but it'll also do the preliminary finite element analysis for the slabs as well. So it'll show you the different contours and magnitudes of the contours as well for different cases. And so on. And so since this is done in the cloud, you can log in anywhere in the world and gather this information from your project. You don't even need to have Revit Structure open. You could just log into Autodesk 360 and download your cloud analysis. So what we're going to do next here is we're going to bring in the results from the analysis into Revit Structure. So after I click the results button, you can see that a new window pops up. It's downloading the results from the cloud. And it's bringing that over right now so that we can kind of see results within Revit Structure. See that a new window pops up, and you can start to change your view to whatever you want to see. So if you only want to see, a specific reaction, maybe you want to see movements for your reactions as well, and maybe you're also interested in the finite element analysis for the slab. And depending on which moments you want to see, you could portray that on the screen as well. So we're going to go and click Apply. Oh, and we need to make sure that we choose the appropriate load combination. And it's downloading the results. And here in a second, you'll see that information pop up on the screen in this view. Okay, and here you go. Here we have our analysis that we ran, and we have the specific information that we're interested in looking at. So when I close this window, we can see how Revit has brought that information in from Autodesk Cloud 360 analysis. Here we go. And you could see the different levels of the colors for the contours and what they mean and so on. And since I actually put in a couple of reactions that I wanted to look at. You'll notice that they come up right on top of each other. And the great thing about this is that you can open up a sheet, and it's just like any other view in Revit. You could place it on your sheet for your analysis, however you need to orient this, or if you need to include this for your project very easily. You could place it on the sheet. This is definitely a great tool to use as you're designing your project. Maybe you have several iterations before you do a real analysis, and you could definitely utilize the cloud to do preliminary analysis for you. So what I'm going to show you guys next is the App Store that comes with Revit Structure 2013. And this behaves very similar to if everyone's uses Apple, like the Apple Store or a Droid Store. And you can literally download add-ins from the Exchange store here. So you could search, you could find whatever you need, and literally download it and install it for your version of Revit. I tend to use this structure coping tool, or this add-in. It's pretty useful. And you could buy some, you could try some. Some of them come free. But yes, it's definitely something new and very interesting, because there's a lot of apps that are coming out all the time. So it's just to make your life easier when using Revit. You can see after you've installed it, it comes in under the add-ins tab. And there's your add-in. All right, and so to recap what we've seen so far today, there have been major updates to design and documentation, as well as analytical modeling, integration with Navisworks, and structural usage via the cloud. So that concludes our presentation for today on the new features within Revit Structure 2013. Thank you for joining us for this webinar, and I'm going to go ahead and hand it over to Megan.
All right. At this point, we'll be accepting any questions you might have. So you just type them into the webinar toolbar under questions, and Henry will be happy to answer any questions you might have about the software. Okay. Henry, I have my first question for you is, for cloud analysis, how does Autodesk analyze the structure when it's sent to the cloud?
Oh, that's a very good question, Megan. So the way that Revit and actually Autodesk has designed this is to use the same engine from robot structural analysis. So when you send it over through the cloud, it's actually using basically what it would use for robot structural analysis. So that's why it's very, very useful to integrate between, when you're doing the cloud analysis, to integrate with robot structure as well, because it can communicate very closely and very well.
Great. Well, that seems to be it for today. Thank you, Henry, and thank you for everyone for attending today's webinar. We hope you found this helpful and educational. If you have any other questions, or if anything comes up, you think of anything, we'd be happy to help. To learn more about the new Autodesk 2013 solutions and how to get started, you can visit us at www.microdesk.com and the URLs you see here, or give us a call. Thanks, everyone. Have a good day.